In the last video, we looked at the AND rule for independent events. We said two events were independent if the outcome of one didn't affect the outcome of the other. We're now going to move on to dependent events or conditional probabilities. What we're going to do is take our bag of shapes. We can see there are 8 shapes in the bag. We've got 4 squares, we've got 2 triangles, and we have 2 circles. I'm going to choose 2 shapes from the bag. After I've chosen the first one, I'm not going to replace it. What we're going to do is use a tree diagram to build up the probabilities now of picking each shape. So this is a tree diagram, and we looked at one of these in the last video. So let's go ahead and start labelling this up. So what we're going to have now is pick number 1, and an event for pick number 1 might be drawing a square. So pick number 1, and then we're going to have pick number 2. So pick number 1 and pick number 2. So with pick number 1, I can either pick a square, a triangle, or a circle. If we think about pick number 2, we could have a square, a triangle, or a circle. So if I've picked a square, I can still pick another square. There's nothing here. If there was only one of the other shapes, then we'd have to alter the tree diagram, but we've got enough to pick 2 from. So square, triangle, circle. Square, triangle, circle. So if I now look at the probability of picking a square, there are 4 squares out of 8. I can of course write that as 1/2. I'm going to leave it as 4 over 8. Triangles, there are 2 out of 8. And circles, there are 2 out of 8. If we add these probabilities downwards, down the branches, we will always get 1. These are the 3 outcomes that are possible. The first outcome is picking a square, second one is a triangle, third one is a circle. Okay, let's say now when I picked one out, I did pick a square. I'm not going to replace this now. What we'll see now is this particular event, the outcome of this particular event will influence now the others. If I think now, if I picked a square on the first one, there are only 3 squares left and only 7 shapes. So on the second pick, I've got a choice of 3 squares, but only 7 shapes. If I picked a square on the first one, I've not picked a triangle. So we can see in the bag, there are still 2 triangles and there are 7 shapes. Circles, there are still 2 circles out of 7. All of these will add to 1. 3 plus 2 plus 2 is 7. That gives me 7 out of 7. Let's say on the first pick, I didn't choose a square, but I chose a triangle. So if we did that, what we'd have now is the probability of a square. Well, there are 4 in there. So the numerator doesn't go down, it's just the denominator. 4 out of 7. There's only 1 triangle left, so we've got 1 out of 7, and then we're going to be 2 circles, so that's 2 out of 7. If instead on the first pick I didn't choose the triangle, I chose a circle, we can see on the second pick the probabilities have changed. So they're no longer what they were if these were independent events. They would be independent events if I put the circle back in. But as soon as I take it out, we have conditional probabilities. How many squares are there? Well, there are 4 out of 7. There are 2 out of 7 triangles, and there's only 1 circle. So we'd have 1 out of 7. If I, for example, now chose the next one, while we're here, I could now do another branch, pick number 3. But as we could see, now we wouldn't need to include the circle, as we would end up at this stage with 0. You could continue it, but we can see there's 0 chance of doing it. So this now is for 2 picks when we don't replace the first one. We say that this is non-replacement, and non-replacement is an example of conditional probability. You will see other examples of conditional probability, not necessarily with replacement and non-replacement, but this is just one particular example. So let's look now at the probability, and we'll put this back in. Let's look at some probabilities from here. So the first probability that I'm going to look at is choosing 2 squares. So the probability of a square and a square. So this time I can see I'm going to use the word and When we use the word and, we multiply. If we see the word or, we add. If we see the word and, we multiply. So what I'm going to have now is the following. I go up the branch with S and S. So I have 4 over 8, which if you like you can write as 1/2, multiplied by 3 over 7. So all I'm doing is following the branches. We can see now that that's going to give me 3 over 14. So the probability of me choosing 2 squares will be 3 over 14. If I said now the probability of 1 square and 1 circle, we could have the probability of a square and a circle, or we could have now the probability of a circle and a square. These will give us the same probabilities. I'm just going to go through them as they are, but you can do 2 lots of either one. So if we look at this one, and I'll just highlight what I'm going to do here, I'm going to look at 2 different branches. So on the first one, I'm going to do the square and the circle. So I'm going to go up to the square, and then I'm going to go down to the circle. I'm going to multiply those 2 probabilities. What I'm then going to do is add to that, because it's or, coming down now to the circle down this way, and then I'm going to go up the square. So all I'm doing is calculating one probability and adding it to the other. So if we do that, let's go ahead and put those on. Square and circle. 4 over 8 multiplied by 2 over 7, or we could say now 1/2 multiplied by 2 over 7, which is going to give me a simplified fraction of 1/7. Often when you're doing these, writing them as unsimplified fractions makes it easier when you're adding the fractions. So if we look at the next one, what we've got here is a circle. So the circle is 2 over 8 or 1 over 4 multiplied now by the square, which is going to be 4 over 7, and we can see that's going to be 1 over 7. So this one is 1 over 7, this one is 1 over 7, so we would need to add these, and the probability of getting 1 square and 1 circle is going to be 2 over 7. So I've seen the word and, I multiply, I've seen the word or, and I add. If we wanted to look at the probability of not picking 2 circles, we could do the probability now of picking, and I'll write it here, of now, and I'm going to write it as not a circle and not a circle. We can do now 1 minus the probability of a circle and a circle. So this is a lot easier rather than working all the others out. So if the question was, what's the probability of now choosing when they are both not circles? So all I've done is 1 minus that. So I do from here now, let's do 1 minus, we're going to have this root right here. So 1 minus 2 over 8 or 1/4 multiplied now by 1 over 7. So that's going to give me 1 minus 1/28. I'm just looking at the fraction here, which is going to give us a total of 27 over 28. So 27 over 28. So the probability of something not happening is 1 minus the probability of it happening. And we saw that in a previous video. So this is how we can use a tree diagram. You certainly don't have to use a tree diagram. You could just do a sample space. So if I looked at the sample space based on this, we could write that the sample space was S, 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 T, S, C. So all I've done is follow this branch and this one, this branch and this one, this branch and this one. We're going to have 9 of these. The next one would be TS, TT, TC. So I'm listing these now systematically, TC. And then finally CS. So CS, we could have CT, and we could have CC. So 9 possible combinations here, and we could work with them. So whilst a tree diagram is helpful, it is not essential. You're not forced to do it unless you're told to do one. Okay, let's do some questions. A bag contains 3 red counters and 4 blue counters. 2 counters are taken out of the bag. Find the probability that A, both counters are red, B, both counters are the same colour, C, the counters are different colours. We could use a tree diagram or we could use a sample space. I'm going to look at both and you can choose from there. So what we've got here now are two possible different colour counters, and we're going to have now pick number one, so pick number one and pick number two. So two are taken out. This means that it's non-replacement. You don't take them out at the same time, you take one out, which is pick number one, and pick two comes out afterwards. Quite clearly you're not going to put pick one back in the bag, so it becomes conditional probability. If it's independent, you will be told that they're going to be replaced. So what I'm going to have now is red, and I could write here either blue or not red. What I'm going to do to make it easier is just write blue. So on the first one we can see there are 3 red counters out of 7, therefore we've got the 4 over 7 for blue. If I picked a red on the first one, we only have 2 in there out of 6. If I picked a red on the first one, there are still 4 blue ones out of 6. If we now picked a blue on the first one, there are still 3 red in, so we have 3 out of 6. And if we picked a blue on the first one, there are only 3 left now, so we have 3 out of 6. On the next one, we would be down to a denominator of 5. So what do we want? Both red. So we want now the probability of red and red. So if we look, all we need to do is follow this branch right here. So this is going to be the 3 over 7, and we're going to multiply this by 2 over 6, or if you like, 1/3, and that will give us now 1 over 7. The probability on the next one is that both counters are the same colour. So we could have now red and red, or we could have now blue and blue. We already know the probability of red and red, that's going to give us 1/7. If we look at the probability of blue and blue, it's 4/7 multiplied by 3/6, which is 1/2. And that is going to give me now 1 over, what we're going to have, 1 over 7. So let's just check that. 4 over 14, 4 over 14 is going to give me 2 over 7. So let's just write that. That'll be 2 over 7. So I've got 1 over 7. I need to add to that 2 over 7, which is going to give me 3 over 7. The counters are different colours. At this stage, if we just consider what this is saying, and I'll highlight this, what we've just worked out is red and red, or we've got now blue and we've got blue. The only 2 that are left to do, if we look at this, is the red and the blue, so we could go that way, and then the blue and the red. So these are the only other 2 possible combinations that we could have, and all we would need to do is do 1 minus this answer right here. Just think of the sample space on here. We can have red, 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 blue, we could have blue, red, and blue, blue. We've just found out now the probability of these 2, so all we've got now are these 2 left, so it'd be 1 minus 3/7, which is going to give us 4/7. You can of course work that out if you really want. You can multiply this one by this one, so if we did that, 3 over 7 multiplied by 4 over 6, which is 2 over 3, and then add to that now this one down here, so we've got the 4 over 7, so 4 over 7 multiplied by the 3 over 6, which is going to be 1/2. This is going to give me 2 over 7, and this is going to give me 2 over 7, which is going to give me 4 over 7. Quite clearly we can see it's exactly the same, and these are all of the possible outcomes. Therefore, they're always going to equal up to 1. So you don't have to keep doing the same thing all the time. Okay, let's look at this one. A bag contains 3 red balls, 3 green balls, and 3 yellow balls. 2 balls are taken out of the bag. What is the probability that A, both balls are yellow, B, both balls are the same colour, B, both balls are different colours? So let's go ahead and do this on a tree diagram. By this time, you might simply be writing sample spaces and working them out from there. So on the first pick, all of these are very similar examples, and in a later video we'll do some more challenging exam style questions, but hopefully this gives you some idea of what you should be doing. Pick one and pick two. So we've got red, we've got green, and we've got yellow. So red, green and yellow. Now I'm going to write this then. There are 9 balls in total, so this is 3 out of 9, this is 3 out of 9, and then we got 3 out of 9. So we're going to have red, we're going to have green, and we're going to have yellow. We've got now red, we've got green, we've got yellow, red, green and yellow. So if we consider on picking on the first one that we get a red, we're going to have now 2 out of the 8, 3 out of the 8 and 3 out of the 8. We would have now 3 out of 8, 2 out of 8 and 3 out of 8. If we looked at this one, we would have 3 out of 8, we would have 3 out of 8, and we'd have 2 out of 8. So both balls are yellow. So the probability of yellow and yellow, we're simply going to follow that branch, yellow, and then this branch, yellow. So we're going to have on here 3 over 9, which is 1 over 3, multiplied by 2 over 8, which is 1 over 4, and that gives us 1/12. So the probability that they're both yellow is going to be 1/12. Both balls are the same colour, so we could have now the probability of yellow and yellow, as we've just found. We would add to that now the probability of red and red, and we would add to that the probability of green and green. So I've got 1/12. So this is yellow and yellow. I'm using the word and, so I'm going to multiply. So we know that that's 1/12. Red and red, if we went this way, it's a quarter multiplied now by 1/3, so we'd have exactly the same. So we would add 1/12, and again with the green we'd have now 1/3 multiplied by 1/4, so we'd have now plus 1 over 12. Or you could say these are all the same. We're going to have 3 over 12, which is going to give me now 1/4. So 3 over 12 is going to be 1/4. If we now look, both balls are different colours. At this stage we could work these all out, but what we're going to do is look at how we can make this easier. So if we look at the sample space, we've got red, red, we've got red, green, we've got red, yellow, so red, yellow. We've got now green, red, we've got green, green, we've got green, yellow. If we look at the next one, we've got yellow, red, we've got yellow, green, and we've got yellow, yellow. What we've just found out is this one, we've got this one, and we've got this one. All of the other combinations have different colours. Red and green, we've got red and yellow, green and red, green and yellow, yellow and red, and yellow and green. So all I'm going to do is 1 minus the calculation we've just done, which is going to give us 3/4, rather than doing all of these over and over again. Okay, let's move on to another question. The probability that a football team wins their next match is 0.3 if they won their last match, 0.8 if they lost their last match. In part A, we need to find the probability that if a match is lost, the next 2 will be won. Okay, this is slightly different. In B, we ask to find the probability that if a match is won, the next 2 will be won. So what we need to do is just slightly change this, because what we've got here now is for a probability where something is given as a result of a previous outcome. So what I'm going to do now is start this one. If we start here with lost, so what I'm going to do with the tree diagram is start at this point. Given that the last one was lost, so we're going to start with lost. So if we consider now, I'm going to have win or lose. If I follow this table right here, we can see the probability that a football team win their next match is 0.3 if they won their last match, or 0.8 if they lost. So what I'm going to have here is 0.8. Just consider now, I'm starting this given that the last match is lost. Therefore, these have to be equal up to 1, so that's 0.2. A common error is to somehow put 0.8 and 0.3. If we now look at this one, this is going to be win or lose. So what we've got, we'll say now that this is going to be match number. Let's say this is match 1 after the loss, and this is going to be match 2. We need to be careful here. If they won their last one, the probability that they win their next one is 0.3. Here it's 0.7. If we look at this one, we've got win and lose. They've lost their last match, so the probability that they win is 0.8, and the probability that they lose is therefore 0.2. So this is given something has already happened, so you can see a slight variation. So what we need to do now is find the probability if a match is lost, which we've just said, this one is lost. The next two will be won. So all we're doing is following up these branches, and we'll do the probability of win, and I'm going to use the notation now, win and win. We're going to have 0.8 multiplied by 0.3, which is going to give us 0.24. Okay, let's look at the next one now. From here, I could do this one off the same tree diagram. I'm going to start a new tree diagram to hopefully, if you weren't comfortable with what I've just done, do another one on here, and it should make sense. So this time, given that the last match was 1. So let's go ahead and do that. So let's do that. So what we've got here is the last match was 1. So we start here with that they win. So they win their match. We can see here that if they win their last match, the probability that they win their next one is going to be now the 0.3. So let's go ahead and put that on. So I'm going to have now, this is match, the first match after they've just won. So match 1, and we're going to have match 2. So match 2. So win and lose. So this is going to be 0.3. Therefore, this is going to be 0.7. All I'm doing is taking this from here. So 0.3. Okay, so if we have this one, the probability that they win this match, if they won their last one, is going to be 0.3, and this is going to be 0.7. Remember, each of these add up to 1. Now, with this one, the probability that they win if they lost their last match, and of course we've got a loss just here, is going to be the 0.8. So we can put on here now 0.8. So 0.8, and this is going to be 0.2. So what we're asked now, find the probability that if a match is won, the next two will also be won. So in this scenario, what we need is the probability of win, and I'll write and this time. We want win and win. So we can see that this is going to be equal to 0.3 multiplied by 0.3, which is going to give us 0.09. So if they've won their last one, the probability that they win the next two is going to be 0.09. So that's a brief introduction to conditional probabilities or dependent events. In a later video, we'll look at some tougher exam style questions.